Question number 7. Show that the relation R in set A of all the books in a library of a college given by relation x and y, xy such that x and y has the same number of pages is an equivalence relation. So here they have given a relation R in a set A of all the books in a library. So in a books we are searching that books of library of a college, given that we have taken two books, saying that book X and Y have the same number of pages, means two books should have the same number of pages, and we have to show that it is an equivalence relation. So what is equivalence relation? We have to prove reflexive, symmetric and transitive. That is reflexive, symmetric and transitive. So we have to prove reflexive, symmetric and transitive to make it as an equivalence relation. So now solution, the first we will do reflexive. So reflexive, let's write a relation is reflexive if A and A belongs to A comma A belongs to R, means the same book belongs to the same book as the same number, same book should have the same number of pages. So we know that same book, if you take, both the books will have the same number of pages. So same book have same number of pages. So you have same number of pages. So the book will have its own pages. So this is therefore A comma A belongs to R. Therefore R is a reflexive. So R is now reflexive. Now next we will prove for the symmetric. So symmetric. So what is the condition for symmetric? A relation is symmetric. So if relation is symmetric, if so A comma B should belongs to R, then B comma A also belongs to R. So A comma B belongs to R means B comma A also should belongs to R. So here if we are taking two books which has the same number of pages, so we'll write here as here A comma B belongs to R. So that implies A and B have same number of pages. So if we take like 200 pages, if book A and book B has 200 pages, both book A and book B has 200 pages. If we write ulta, means B comma A. So B comma A will also have the same pages. Book B will have 200 and book A will also have the same pages. So we'll have same number of pages. That is 200 only it will be. So therefore B comma A also belongs to R. So therefore R is a symmetric. So now we have to prove for the transitive. A relation is a transitive if AB belongs to R and BC belongs to R, then AC should belongs to R. So if we are taking a 3 book A, B, C has 200 pages. So here we'll see that here A comma B belongs to R. So that implies that A and B have same number of pages, that is 200. Okay, and B comma C belongs to R, that is B and C have same number of pages. So both will have 200 again. that implies that even A also have 200 number of pages and C also have 200 pages. So A comma C also have the same number of pages. So it is pages, that is 200. So A comma C now belongs to R because A comma C also have the same number of pages. Therefore, R is a transitive. So R is a transitive. So now we know that R is the relation is reflexive, symmetric and transitive. Therefore, the relation R is equivalence relation because it satisfies reflexive, symmetric and transitive relation. So this relation is called equivalence relation. Question number 8. Show that the relation R in unset A 1, 2, 3, 4, 5 is given by a relation AB, that is A minus B is even and is an equivalence relation, and show that all the elements of 1, 3, 5 are related to each other and all the elements of 2, 4 are related to each other, but no element of 1, 2, 1, 3, 5 is not related to any element of 2 and 4. So this question, they have given a relation with a set has 1, 2, 3, 4 and 5. They have given a set A 1, 2, 3, 4, 5 and they have given a relation that A and B where A minus B in modulus is equal to A is even. So here A minus B mod should be even and you have to prove it has a equivalence relation. So this is the first part of this question. Then first let us solve the first part of this question. So there, what do you mean by A minus B modulus? If it is a modulus, so usually in the mod, if we take a modulus of 2, so mod 2 is nothing but a 2. But modulus, whenever the modulus is there, so always it will be positive. If I am taking as minus 2 modulus, then it will be 2. It will become a plus. A negative will become a plus. So any positive will be positive and negative will be plus. If within the modulus there is negative, then it will become a plus. So this is called mod. So first we will prove for the equivalence relation, that is reflexive, symmetric and transitive. So first we will check for the reflexive. So reflexive. So a relation is reflexive if A comma A belongs to R. So it should be a reflexive if A comma A belongs to R. So if we take any one of this number, like if we take 2 minus 2 mod. So 2 minus 2 is nothing but a 0. So 0 modulus will be always a 0 and 0 is an even number. So it satisfies even if you take 4, 5, 1, 2, 3, 4, 5, any number, if you subtract by itself, it will be always 0 and 0 modulus will be always 0. So we will write since A minus A mod is equal to 0, that is module of 0 is 0, is always even. So A mod minus A is an even. So therefore A comma A belongs to R. So R is a reflexive. So R is a reflexive. So next we have to tell for the symmetric. So a relation is symmetric. If we tell if a relation is symmetric, if A comma B belongs to R, then B comma A should also belongs to R. So here we'll take any number, like we'll take 3 minus 5. So 3 minus 5 a mod is nothing but what would be 3 minus 5? It will be minus 2. So what is it? 3 minus 5 will be minus 2 mod is, so modulus of minus 2 is 2. And if we take ulta, this will be my A and B. So if I do now ulta, that is B minus A. So B minus A is nothing but 5 minus 3 mod. So 5 minus 3 is 2. So modulus of 2 is 2. So you get the same answer for this question. So both are even. So since we can write it as, we know if A minus B mod is an even, that implies B minus A mod is also a even. So therefore AB belongs to R and BA also belongs to R. So therefore R is a symmetry. Okay, now we have to prove for transitive. So a relation is a transitive. So if relation is a transitive, if AB belongs to R and BC belongs to R, then AC should also belongs to R. So here AB belongs to R and BC belongs to R and AC should also belongs to R. So we will take here an example ABC. If we take 1, 3 and 5. We are taking 1, 3 and 5. So 1 minus 3 mod will be minus 2 mod will be 2. Again, if we take 3 minus 5 mod will be minus 2. Again, it will be an even. Again, if we take 1 minus 5 mod will be minus 4 mod will be 4. So all these three will be an even number. So even 1 minus 3 or A minus C is also an even. So A minus B and B minus C mod is a even. So as we see A minus C is also, that implies that A minus C is also even. So therefore A comma C also belongs to R. So here we have seen that AB is also belonging to R and BC is also belonging. Now AC is also belonging to R. So therefore R is a transitive. So you know that here we have we have proved that it is a reflexive, it is a symmetric and transitive. Therefore R is a equivalence relation. Valence relation. This is the first part of the question. Now the second part is show that all the elements of 1, 3, 5 are related to each other and all the elements of 2, 4 are related to each other. But no element of 1, 3, 5 are related to any element of 2 and 4. So here the elements they have given as 1, 3, 5. So 1, 3, 5 are related to each other. How they are related to each other? If we subtract 3 minus 1, it is an even. Again 5 minus 1 is an even. So you get the whatever, if you do subtraction between these numbers, you get an even number. The same way if you do 2 and 4, if you subtract 2 and 4 or 4 and 2, you get the even number. But here in this element, here the 1, 3 and 5 are related to 2 and 4. It is not, because this is an odd and this is an even. If you subtract an odd with an even, you get always an odd number. But here the relation is given that it should be a even number. So this is not related. We'll see that how to write this. So we write as all the elements of 1, 3, 5 are related to each other as they all are odd. So 1, 3, 5 all are odd. So the subtraction of two odd number is always even. So 1, 3, 5 are related to each other. They were next is all the elements 2 and 4 are related to each other as they all are even number, and the subtraction of even numbers will be always a even number. Subtraction of two even numbers will be always the even number, but no element of 1, 3, 5 are related to 2 and 4 because the formal set is a set of odd numbers and the later set is a set of even numbers. So the subtraction of odd and even numbers is always a odd, but our relation tells that the subtraction of any two numbers should be even number, but here the odd number and the subtraction of even number, so subtraction between odd and even numbers will be always a odd. So the both odd and even number will not be related to each other. Question number 9. Show that each of the relation are in a set A where x belongs to z, that is 0 is less than or equal to x and less than or equal to 12, given by the first, under that first question is r is equal to a comma b, that such that a minus b is a multiple of 4, and the second one is r is equal to a comma b such that a is equal to b is an equivalence relation, and also find the set of all the elements related to 1 in each cases. So in this question they have given us a relation R with a set x belongs to z. So z is what? Z is nothing but a integers. So we know that integers are starts all the negative, 0 and the positive numbers are being included in integers. So that is integers are z is nothing but minus 3, minus 2, minus 1, 0, 1, 2, 3. So dash dash. So all the negative numbers, 0 and the positive numbers are the integers. And here they have given us the x value. So the x value should be between 0 and 12, means it should include 0 and 12, because here few times here they have given us less than or equal to, so equal to sign is there. So they have given us a is where x is belongs to z such that a0 is less than or equal to x and less than or equal to 12. So it is 0 is equal to x. So my a will be from 0. It will include 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Only 12 will be there because x is less than 0. If they have given as like this, 0 is less than x and less than 12, here we does not include 0 or not the 12. So only we'll start from 1 to 2. We'll have 1 to 11. Only 1 to 11 will have. But here they have given as equal sign. So we are going to include 0 and 12 as well as in our set. So we have to, and the first question says that here first we will solve the first question, where the first question tells that r, where r is a comma b such that a minus b is a multiple of 4. So here the first relation tells that a minus b mod is a multiple of 4. First we'll see what is modulus. So modulus is any numbers which comes in a mod, it will become a positive. So imagine if you take 2 mod is 2. If you take minus 2 mod is always a 2. So always a negative number becomes a positive and positive number will also become a positive. So first we have to prove for this a minus b mod is a multiple of 4. So the first relation we have to prove with it is the equivalence relation. So first we will check for the reflexive. So reflexive, a relation is reflexive. So if a comma a belongs to R. So A comma A should belongs to R. So first we have to check that the number itself is a number or not. So here we have to see the multiples of 4. So what are the multiples of 4? Will be 0 is also a multiple of 4. 4 is itself a multiple of 4. 8 is a multiple of 4, and as well as 12 is a multiple of 4. So here in the reflexive, a number itself is a multiple of 4. So for an example, if I take 3 and 3. So if I take 3 minus of 3 mod is nothing but a 0 mod. So 0 mod is 0. 0 is also a multiple of what? It is a multiple of 4. So of course it is. So any number you take, any number of minus of itself is a 0, is a multiple of 4 only. So since A minus A mod is equal to 0 mod is 0, which is multiple of 4. So we know that 0 is a multiple of all numbers including 4. So therefore A comma A belongs to R. Therefore R is a reflexive. So R is a reflexive. We proved that R is a reflexive. Next we have to check for the symmetric. So a relation is a symmetric if A comma B belongs to R, then B comma A also should belongs to R. So A comma B belongs to R, then B comma A also should belongs to R. So here I will take a number, any number such as 3 minus 7. So if I take 3 minus 7, so it is 3 minus 7. So A will be my 3 and B will be my 7. So 3 minus 7 mod is nothing but minus 4 mod is again a 4. So 4 is a multiple of 4. Right. So if I take ulta, if B minus of A mod, that is 7 minus of 3 mod is again a 4 mod. So is 4. So you know that these both are the same. Both are the multiple of 4. So since we can write here as here A comma B belongs to R. So we know B. So here 3 minus 7 is nothing but the 4 is a multiple of 4. It belongs to R. That is A minus B is a multiple of 4. Therefore, B minus A is also a multiple of 4. So therefore that is B comma A also belongs to R. Therefore R is a symmetric. So R is a symmetric. Next we have to prove for the transitive. So transitive. So a relation is a transitive. If we tell a relation is transitive, if AB belongs to R and BC belongs to R, then A comma C should also belongs to R. So here we'll take an example as A is 3, B is 7 and C is nothing but the 11. So that is A minus of B mod is nothing but 3 minus 7 is nothing but minus 4. So it is a modulus of is 4 again. If we take, so B minus C is nothing but 7 minus of 11 is minus 4 is again a 4. The same way if we take A minus of C, what is A minus of C is 3 minus 11. 3 minus 11 is minus 8 mod is nothing but a 8. It is also multiple of 4. So this is also multiple of 4. The 4 is also multiple of 4 and 8 is also multiple of 4. So we write this as here here A, B belongs to R, that is A minus B mod is a multiple of 4 and B minus C belongs to R, that is B minus C is a multiple of 4, then that implements that A minus C is also a multiple of 4. So that is A comma C also belongs to R. Therefore, R is a transitive. So therefore, so we have seen that we have proved already it is. So we have proved here that it is reflexive, symmetric, and as well as the transitive. So R is a equivalence relation. So they have asked us to find the set of all elements that are related to 1 in each case. So we'll see which are the numbers which is related to 1 in this case. So here A minus B mod is a multiple of 4. So if we take and we'll fix here hey, A as 1 and we'll check for the all the numbers. So if we take here we'll take as A and B, A minus B mod belongs, you'll say yes or no. So if we take A has 1, we'll consider A is fixed. So we are not taking any other number. So if we take A has 1 and B has 0, so 1 minus 0 is nothing but what you get is 1. So 1 is a multiple of 4? No, it's not. So it is, we will not take. Again, we will take it as 1. So 1 minus 1 mod is nothing but 0. Of course, 0 is a multiple of 4. Yes, we can take 0. So 1 and 1 belongs. Next, if we are taking 2. So 2 is what? 2 is 1 minus 2 is again what? It is minus 1 mod is 1. No, you can't take. If we take 3, so 3 is what? 1 minus 3 mod is nothing but minus 2. So minus 2, 2 is not a multiple of 4. So you can't take. Next, the 4 you will get as 1 minus 4. What is 1 minus 4 is minus 3. No, you can't take because 3 is not a modulus of 4. If you are taking 5, 1 minus 5, yes, it is minus 4. 4 is a modulus. You can take 4. The next with 6, no, 6 minus 1 is 5. With 7 is not possible because 7 minus 1 is 6. 6 is not a multiple of 4. Next is this. Next is 8. If you take 8 minus 1 is 7 is a not more multiple of 4. The next number is 9. Yes, 9 here. 1 minus 9 is nothing but the minus 8. It is a multiple of 4. Yes, you can take 9. 10 minus 1, no, because it is 10 minus 1 is 9. 9 is not a multiple of 4. Then 10. 11 you can take 11. 11 minus 11 is 10. 10 is not a multiple of 4. 12 if you take 12 minus 1 is not a multiple of 4. So here only 0, 5 and 9 is related to 1. So here we write it as, here the set of element related to 1 is 1, 5 and 9. So 1, 5 and 9 are related to 1 because only they, if you subtract with them, you get an even number which is multiple of 4. the second part of the question, where the relation are a comma b such that a is equal to b. So here the relation is a is equal to b, and the set is from 0 to 12 we have a set. So we have to prove that this relation is an equivalence relation. So we have to find out first whether it satisfies reflexive, symmetric or transitive. So first we will check for the reflexive. So reflexive, a relation is reflexive. So if relation is reflexive, if a comma a belongs to R. So here a comma a should always belongs to R, since we have seen that a is equal to b. So in the place of b, if we take a, so a is equal to a. Of course a itself is equal to a. So if you take 1 means 1 is equal to itself 1 only. So since we can write it as, since a is equal to a is always true. So it is always true. A is equal to a is always true. Like 1 is equal to 1, 2 is equal to 2, 3 is equal to 3. So a is equal to a is always true. Therefore, a comma a belongs to R. Therefore, R is reflexive. Reflexive. So R is reflexive. Next, we have to check for the symmetric. So symmetric, when do we say relation is symmetric? Symmetric if A, B belongs to R, then B comma A should also belongs to R. So here we know that if A is 1, then B will be also 1, because if A is equal to B. So if A is equal to B, so if A is B means if I take A has 1, then B also will be 1. So it belongs to R because A is equal to B. So here this implies that A comma B belongs to R. So it is A belongs to B. Therefore, if we write B comma A also belongs to R, because nothing but I'm changing the position where A is equal to B and B is also equal to A, because 1 is equal to 1. Again 1 is again equal to 1. So therefore, that is BA also belongs to R. Therefore, R is a symmetric. R is a symmetric. Next, we have to check for the transitive. So transitive, what the function says, if a function is transitive, if AB belongs to R and BC belongs to R, that implements then AC also should belongs to R. So here if we consider A has 1, if we take A has 1, A has 1, we know that A is equal to B, then B will be also 1. Then if we take B is equal to C, then C is also 1, because A is 1 means B will be 1, and if B is 1 means C is also 1. So how do we write this? If A is equal to B, this implements that AB belongs to R. Okay, and B is equal to C, then BC belongs to R. So therefore A is equal to C, that is AC also belongs to R. C, A is also 1, B is 1 and C is 1. So obviously A is equal to C also. So therefore R is a transitive. So R is transitive. So here we have proved that the relation is reflexive, symmetric and transitive. Hence, all three conditions are proved. So relation R is equivalence relation. It is an equivalence relation. The next we have another part of this question. So we need to find the set of all the elements related to 1. So we have to find all the elements that are related to 1. So we need to find the set of all elements that are related to 1. So one is the element 1 is related to which all element we have to find out. So here we know that the relation is given that R is equal to R A comma B is, so R is equal to A comma B, that is A is equal to B. We know if we take A is 1, then AE is equal to B. So A is 1, then B is also 1. So, and if you take A has 1, B if we take has 2, 1 cannot be equal to 2. Again, if you take 3, 4, 5, 6, any number if you take for B is not equal to. So, only 1 will be satisfied. That is only 1. That is 1 comma 1 only will satisfy the condition, satisfies the relation. So since hence the set of elements related to 1 is only 1. Thank you for watching the video. Please subscribe.